Hello everybody, this is Team 20125 and we have another tutorial today. I'm going to teach you guys how to code your own PID in Java. Right, so last video I taught you guys what a PID was and basically how to tune a PID, right, for a robot. And now today I'm going to teach you guys how to actually code your own custom PID loop for your FTC robot, right? So let's go. Okay, so now we're in Android Studio. Right, so here I've just created a basic class for PID tuning. If you have any problems, if you don't know like what this code means, you should go check out an introduction to FTC Java programming. And if you don't know how to use FTC dashboard, I've also included these links in the description below that I find are really good tutorials. Right, so as you can see, I've just defined a motor and I've initialized it in the initialization of your object. Right, so now let's actually create the PID loop for our test motor. So to do this, we just need a function here. I will name it PID controls. And now we will use several input variables. So we want your reference, which is your target position. We want your state. We want your integral error. We want your last error. And we want your coefficients for your PID, right? So now, as you can see, let me just go back to the initialization here. As you can see, I've set the mode to run without encoder, right? Now, this is very important, as the thing is, there is a built-in PID loop in your DC motor class. Now, the problem with this is that if you use this, you have to use it with your encoder. And the problem with it is that you can only speed up your motor to about 80% of its max velocity, which I don't like. So in my opinion, it's better to create a custom PID loop and set it to run without encoder, or else if you don't have any like high velocity applications, if you don't need your motor to speed up to greater than 80% of its velocity, you can just use the built-in PID loop and you set velocity after you tune the constants, right? So, okay, now in our loop, we want to define our error, which is equal to your reference, which is your target position minus your state, your current position, right? Pretty self-explanatory. And now this is the proportional part. And now we want your integral part, which you can see is here. Integral error plus equals your error multiplied by a timer, which I have not defined yet. And you can do seconds here, milliseconds, doesn't really matter, it will just influence your ki value, right? So I will define a timer, timer equals to elapsed time, like this, right? If you don't know what this means, I've also attached another video in the description, which I find is pretty helpful, but this is just a simple timer in Java, right? Now we have our integral error, and now we want to calculate derivative value, which in this case is just the slope, right? So this is just your classical definition for finding your slope. So y2, which is your error, minus your y1, which is your last error, divided by divided by your time, which again you can do seconds or milliseconds. It doesn't really matter. It will just determine what your KD and it will just determine what your KD constant is, right? So in this case, I like to do seconds. Now we want to set your last error. Sorry, I don't know why I did double there. But you want to set your last error to your current error, as you're not using it anymore. And now you want to return a couple of things. You want to return a list. So this is what I like to return. Yeah, you want to make the function return an array, right? Now I'll explain the reason in a bit, but so you want to return your error multiplied by your KP value plus your integral error multiplied by your KI value, and then you want to return, and then the derivative multiplied by your D value, right? So error multiplied by your KP plus integral error multiplied by your KI and derivative multiplied by KD. That is the first value. And now you want to return your integral error. and then you want to return your last error because you updated them in the loop. Right, so why are we returning the list, right? So the problem that I find with a lot of the tutorials online right now about a PID loop is that they only do a PID loop for one motor, right? So now you might be wondering, what do I do if I want to do a PID loop for two motors, right? So there's two different solutions to this. One is you make a separate function for every single separate motor, or in this case, what I like to do is make a universal PID control loop for every single motor, and then just define your integral error and last error for every single motor, right? So I'll show you what I mean. So here I will define your integral error for your test motor, and then I will define your last error for your test motor, right? Now in your while loop, you want to define your PID outputs. Sorry, you want to make this an array, and then you want this to just be whatever your function outputs, right? So you want your reference, which in this case is your target position, which I've defined here. So you want your target position. You want your state, which is your current position for a test motor. You want your integral error. In this case, it's this variable I've defined right here, integral error tests. And you want your last error, which is that other variable I've defined here, and now you want your coefficients for your PID, right? So in this case, I'll define coefficients like this. Now I'll set all of these to 0 for now. And then you can just call it right here, like this, right? And now to actually update your integral error and your last error, and of course set the power to your motor, this is what you do. Oh, you want to set your test motor.setPower. You want to set that to the first position in your array. You want to update your integral error to the second position in your array. You want to set your last error to the third position in your array. Okay, as that is what that's what I have returned right here, and I forgot a semicolon. Now you're done your PID loop, right? Now you might be wondering why this is called PIDF and why there is a fourth constant right here. Now F stands for feed forward, and this is more commonly used for velocity PID loops. So what you do is in your return statements for your power value, you want to add another value, which is your reference multiplied by your KF coefficient. Right, so this just sets a constant power to your motor, and this is typically used for velocity, right? This can be used as a substitute for integral in some cases, but I wouldn't recommend it. So, yeah, so now you might be wondering, what do I do if I want to use two motors in the same PID loop, right? So this is what you do. So you want to go, I will define another motor like this, and you want to associate that motor with its own integral error and its last error, like this, right? And I will just simply define or initialize it, and then you can do set the mode, you can set the zero power behavior. But so now in your PID loop, you want to associate another PID outputs 2, and then you want to do the same PID controls. PID controls, and so your target position, your current position for your second test motor, and then your integral error for the second test motor, your last error for the second test motor, and then your PID coefficients, like this. And I just have to define a new variable to assign it like this. Oh, there is a spelling error. something like this, and then you can literally copy paste this into here, and then this is all you have to do. Simply like this, right? And so yeah, I've seen a lot of other YouTube tutorials, and they only do a PID loop for one motor, but this is how I do it if you want to do more than one motor. And so yeah, PID loop is very powerful in this sense, and the last thing you want to do is reset your timer. Then that will actually give you the accurate integral and slope calculations. So that's all there is to it. And essentially, a PID control loop is just a math, as you can see here, and it's really powerful after you correctly tune your KP, KI, KD, and occasionally KF. You can get a really accurate motor that when you want to set it to a target position, it will set itself to that target position very, very quickly. So thank you for listening to this tutorial. This is Team 20125 with a video about PID controls. Hopefully you guys can take this into your own robotics programming. And so yeah, see you guys next time. Thank you for listening.